All right, guys. So I'm on the Savvis Realize page, and you'll see something similar to this for your assignments because I have assigned all this to you. Um, and now, like, don't think I'm assigning like not every single one of these is an assignment. Okay, you're only gonna have basically one assignment. Okay, and that is at the end. If you follow my cursor down here, this last one is a Math Excel. All right, that's going to be your homework assignment. Everything else is just a resource for you or an example to look back on so that you have it at all times. So that's why if you're only in class really once a week. Um, so if you're at home, you're like, oh man, what I forget that example that was there. You can look back and see this. Okay. So I just want you to be aware of that even though everything, technically is assigned to you, all that you really have to turn into me for a homework grade is this Math Excel for school. Okay. Now, I strongly encourage you guys to look through all this. It really, like, I know it looks like a lot. It should take you 5 to 10 minutes. That's it. Seriously, that is it. I promise. Just to be aware of it, and then that way you can go back if there's a problem in your Math Excel homework, and it'll get your homework done a lot faster if you know what you're doing versus trying to struggle through it without actually looking at this stuff. Okay, so I am going to take you through on this video. I'm going to take you through all these things so that way you kind of understand a little bit more of what's going on here. So the first thing is we have some terms that we need to go over. And so looking here, we have three terms that I want to talk about. All right. And it shows you, it has a description of what it is. It has a diagram of what it's going to look like a picture. And then it has notation. And some of you guys might not have seen what notation. Notation has an N in it. And I also think like name has an N in it. All right. So that's how I remember those things. Notation is really just a way to name something. Okay. So if you look at the first term that we have is a point. Okay. It has a location. It has no size. So even though we use a dot, it's technically has no size because it's in 2 dimensions. All right. So we have P here, we have a dot next to it. So in our notation, we're just going to kind of read this as point P, okay, point P. Now, we are going to use points to name different things, okay? So if you scroll down here, we have a line, all right? A line is an infinite number of points, and we denote that it's infinite by looking at these two arrows, okay? So that means it goes on forever in either direction. Now, when we're naming it, if you notice over here in the notation section, all right, this is the notation section, the naming notation, all right, we have arrows on that little symbol above AB. So that just shows that it's a line that goes on in every direction. So that's how we're going to name it. So we put that little line above A and B, okay? And this is where why just AB? Well, this is where the mathematicians decided a long, long time ago that when we are naming a line, we are only going to use 2 points because that is the bare minimum. If you have 2 points and you connect those 2 points, then you have a line. Okay, even though there is infinite number of points on this line, like I could just there's an infinite number of points. All right, this thing goes on forever. That's how we make that line. Okay, and even though there might be more points on the line, even though they might give you in the problem like C and D and E and whatever, it doesn't matter. All right, it's still the same line. We're still going to name it as AB. So that's where something in your notebook, it would be good to have that we need exactly, okay, exactly 2 points to name a line. So that would be something to put in your notebook, write down real quick. Exactly 2 points. So we don't need 3, we don't need 1, we don't need 4, 5, 6, 7, whatever. Even though there might be 4, 5, 6, 7 points on that line, it doesn't matter. All right, there's an infinite number of points. We only need 2 of them to name the line. Now, if you look, the other thing that we have on here is this this character right here, and it's an L. It's supposed to be a cursive L. And some people see like, oh, it looks like an E. I know it's supposed to be a cursive L, okay? So normally, like when you have a test or something, we'll have, it'll be a character that you know, all right, and you can just write that character down. You're not gonna have to say it. So um, in here, we have that character. It is a cursive L. Now, if you notice, all right, even though I drew that, there is no dot next to L. L is just there so that we can name this line. It's another way to name the line. So we have two different ways. All right, two different ways. Our first way and our second way. So we talked about the second way, the AB. Now the first way here is this line L. Now that L might not be there. Now, saying that, A and B might not be labeled on the line as well. So you just have to be careful. There's different ways to name this line. So if there is a character there without a dot next to it, we can name it as line L. Okay, that's a different way. I think about this as like a nickname. So if you have a nickname, that's another way to name you. You didn't change. You're still the same person. All right. It's just another way to name you. Now, if we're moving on to a plane, and a plane is an infinite number of points, all right, on a flat surface that extends in every direction. So it's an infinite piece of paper is what a plane is, okay? And typically you'll see it as a piece of paper or like a sides in a 3D figure, whatever. So anyways, plane. The best way that I can explain something that's infinite, because our world is not, infinite. The earth is not infinite. It ends, okay? But the best way that I can explain this so we can have kind of a picture in our head, if you just like close your eyes for a second, and think about if you're on a boat, okay? You're on a boat and you're going out in the ocean, okay? And you're sailing on the boat. We're out there. You can see the land, and then you get to a point where you cannot see the land anymore. There's no shore there, okay? So every direction that you look is just water. It's just blue. That's all you see is just blue every direction. There's nothing around. That's kind of what I think about when I think about a plane. All right. Every direction you look, there's just this plane. It just keeps going on forever. This flat piece of paper that just goes forever. All right. So that's what a plane is when we are naming a plane. If you notice here, we have plane XYZ. If you notice X, Y, and Z all have a dot next to them, denoting that they're a point. All right. So when we're naming a plane, we need exactly 3 points to name a plane. And that would be something that you want to write down. All right, so that you have with you, you have something handy right there so you can look back. So exactly 3 points. You don't need 2, you don't need 4, you don't need 7, you don't need 10, you don't need 1. You need exactly 3 points, okay? Now the other way to name a plane, and if you look on there, we have this character M, all right? And there's no dot next to M. There's no dot. So it's not a point. M is not a point, okay? M is just like we had with L right there. M is the same thing. This time we just use a capital letter instead of a cursive letter, okay? And so if you see that M, that's just another way to name this plane, okay? So we can call it plane M. All right. So guys, that is all I have for this part. So what I'm going to do is I'm going to go back, and guys, if you need to like see that for a little bit longer, just pause the video, okay? The next thing, we got to go to some defined terms right here. And so for this, we have just some different ways to name different things. So we have a segment. So a lot of times, guys, we'll be dealing with segments because, again, it's hard to deal with something that's infinite. So if we have a segment, all right, if you notice, it has these two endpoints. So it stops, all right? It stops at A and it stops at B. Now, a segment is kind of just like a line, and that's where we only need 2 points. Okay, so we need exactly 2 points again to name this segment. So there could be, more points on here. It doesn't matter. We just need 2 points to name the segment. And when we're naming the segment, if you look over here, our naming tool, we, instead of putting those lines on there that, to know that it went to infinity, it stops. So all we do is we just draw a line above it that stops. Okay, so that's all we do when we're naming a segment. Okay, the next thing that we have is array. Okay, so array consists of one endpoint. Okay, and then all the other points on the line on that side of the endpoint. So what we're saying is it has one endpoint and then it goes on forever. Okay, in the other direction. That's all array is. And so if you look, and I hope you guys are kind of seeing a pattern now, like this ray looks like this. All right, if I didn't use any characters to name it, isn't that what we have above the MN? All right, it's just a line with an arrow going in one direction. So that's how we're naming things. It's kind of what we're just drawing a picture of it, putting it above the 2 points on that whatever line, segment, ray, whatever, and that's how we're naming it. Okay, so we have MN. Again, we only need 2 points to name this ray. So we have MN. That's what a ray looks like. A little diagram of it. That's why we put it above the MN. So moving on, we have opposite rays. Okay, so if you look at this, opposite rays, and this is when we're talking about opposite rays, we have ray TU. Okay, all right, and we also have ray TS. I'm going to change colors here. TS. Now, if you notice, a ray goes on forever. So if we're looking at that, when you just look at that without the colors, it looks like a line. Okay, so opposite rays form a line. So a question might ask you like, hey, what are the 2 opposite rays that form this line? All right, the best way to do this is to find the point in the middle. All right, and then go one direction, TU. All right, and then go the other direction, TS. Done. Now, the last thing, and this is important, guys. So this is something that we are going to use for the rest of the year, okay? The rest of the year. Angles, all right? And naming angles. Because what you really need to know this is because they're going to ask you questions about angle whatever, and there might be like 6 different angles in there, and you have to pick out the right one, okay? So for this, again, we have different ways to name it. The first way is angle Q, okay? And that's a non-specific way to name the angle, okay? So if you look here, angle Q is what we call the vertex of the angle. It's where the angle starts, okay? So it starts at Q, okay? That we got that point Q, all right? And then it goes out in either direction, okay? And that's why we put those arrows, goes out to infinity in either direction. So it starts at Q. That's the vertex of the angle. So when we're talking about the vertex of the angle, that could be a way to name it. Now, the trouble we get is if we have this. What if I have this Q and I extend this out and I create these other angles? And I put points over here, A, B, and I have these other angles. Now, I don't know what is angle Q, all right? It could be this angle. It could be this angle over here. I don't know. So that's where you have to be very careful when we're naming an angle, okay? So if there's other angles that can be formed from the angle, it's not just a straight up, they give you one single angle, that's it, then you can't name it with just one letter. You can't just name it with just the vertex. So if they give you one angle, you're good, golden, you can label with just the vertex. If they give you more than one angle, they're all connected, then you have to do what I'm going to talk about next, and that's where you have to name it with 3 letters. So they give this name PQR, angle PQR, okay? And this is where, if you notice, we talked about vertex. The vertex is Q, it's where the angle starts. Q is in the middle. So how I think about this is, if you, and I'd like you to do this with me, okay, we're going to start and put your finger on the screen, okay? Put your finger on P, okay? So we're going to start at P. So we have our point P, so you start at one of the points, not the vertex. And then if we're going to draw this angle, we're just going to trace over this angle. We're going to trace along the line, we're going to go to Q, okay, PQ, okay? And then if we're continuing to trace along the angle, then we go to R, PQR. So that's where they're getting the name for this. Now we could also name this, another way to name this is if we start at the other point that is on this angle. If we start at R, so again, put your finger on R with me, okay? So we're going to start at R. Now, if we're tracing along the angle to create it again, we're going to go to Q, and then we're going to go to P. All right, so another way to name this angle would be angle RQP, okay? And the last way to name it is they give you a 2 inside there. Guys, that's going to be the least common way to do it. And then honestly, like just being honest with you, the way we're going to name it is either angle PQR or angle RQP. That's going to be the 2 most common ways to name this angle. And if you notice, like, even though it's one angle, we can call it angle Q. If you just want to stick with something, you're like, I just want something, tell me something that it can always work. Name it with 3 vertices, trace your finger over the angle and you're going to be good to go. Okay. All right. So that's all the terms we have for that one. So I know and guys, this is how it always is going to go. It's just the first section always has a lot of vocab and stuff that we have to go through. So the next stuff, they're going to actually give you some problems. Okay. Distance on a line. If we look here, this is not too complicated. All it says is the absolute value. So I know in reality that you could go, all right, 1, 2, 3, 4, boom, done. Okay. So if they give you that easy of a problem, you can do that. Okay. That's fine too. But just, I want you to understand that it is the absolute value when you're looking at distance. Okay. Again, this is distance. So when I think about distance, I think about it's got to always be positive. What's the only way to make something always positive? Use absolute value. Okay. So that's why we're using the absolute value, because you can't run -5 miles. It makes no sense when I say -5 miles. What does that mean? Some people are like, well, run backwards. If I run backwards, I'm still running a mile. If I run backwards for a mile, I ran a mile. Like, there's no negative distance. Okay. So that's why we're using absolute value. All right. So on to and this is where I said it's going to be a little bit quicker. Okay. So for this problem, just want to take you through the example. So they're asking us, hey, use the ruler postulate. Ruler postulate, we're always going to give some name to it. A postulate, it's assumed to be true. So we have postulates and theorems. Postulates is something that it basically, and just describing it in like common sense terms, a postulate is something that is so simple that it's just known. Okay. So it's just assumed to be true. So we have this, what's the distance, find the coordinates of K and L. So we're finding the distance from K to L. So if we look, we're looking for this segment right here. How far away? We could do our absolute value where we do 16 minus 12. Okay, 16 minus 12 is 4. We're good. Or we could do, 12 minus 16, and that equals the absolute value of -4. Well, what's the absolute value of -4? It's 4. Or you could also just count. I get that too. So anyway is fine. All right. And I think it shows you the solution down here. Yeah, just what I did. So they're looking for the distance from K to L. Okay. So moving on to the next part. So this one, I think we're going to throw in a little bit of algebra here. So this is where you have to use our algebra skills, and you have to use basically definitions. So if we have FG and GH, it tells you there's algebraic expressions, and then it tells you that GH is 16. So G to H is 16. All right. So GH is 16. So it tries to find what's FH. All right. What is the whole length from F to H? All right. What's the whole distance? Well, if we're going to solve this, I'm just going to kind of set this up. You have the solution there. To do this, we know that GH is 2x plus 2, and it's also 16, so we can write an equation since those two are equal. So 2x plus 2 equals 16, and we're going to solve that, and when we do, we should get that x equals 7. All right, I hope I don't have to take you through solving that equation. Subtract 2, divide by 2, all right? So for that, x equals 7. So now what we have to do is we have to plug it back into FG and also GH to find the full length. Well, actually, we know GH is 16. So we just have to plug it into FG. So to do that, you're going to plug it into 3x minus 1. And we're going to plug a 7 right in there. So it's going to be 3 times 7 minus 1. And when we do that, 3 times 7 is 21. That gives us 20. So to figure out what is FH, all we have to do is we just add up 20 and 16. 20 plus 16 gives us 36. We're done. Okay, so that is how we are going to solve that problem. And again, the solution, it went through what collinear is. Okay, collinear points lie on the same line. Okay, so something I kind of glossed over, but yeah, guys, that's just another vocab word. Collinear, it means they're on the same line. So that tells you the step 1, and then it takes you through x equals 7, and so that's where they're getting the 36, the 20 plus 16. Okay, so we are all good to go here. And also, guys, I think they showed you a different way to solve it on here, which is fine. They're using the definition of this, and this is also why I wanted to go through this, because I know some people think like, oh, I can do the 2x plus 2 equals 16. Yeah, that's fine. That's fine. You could also do what they did and add the two expressions up together. So you could add the 3x minus 1 and the 2x plus 2, combine like terms to get 5x, all right, plus 1. And then plug in that x equals 7 and figure out what the total length is. So you'll notice in geometry, there's more than one way to solve a problem, and either one is fine. I don't care. Whichever way you see it is fine with me, okay? So moving on to protractor, shouldn't be too terribly difficult here, guys. I know you've probably used a protractor. If we look on here, you guys should be able to see what is the measure of angle. Actually, let me zoom in a little bit here so we can see this a little bit better. All right, that's a little bit better, guys. So on here, we have the protractor lined up. So if we ask for the measure of, and if I put that M in front, it just means measure. What's the measure of angle A, B, C? And again, if I'm just going to trace it, A to B to C, well, we know that that is going to be this angle, and that is 60 degrees. Okay. Now we also have, and if you notice, B has multiple angles. That's why we can't use angle B, because we don't know what we're talking about. If I ask for the measure of angle D, B, C, notice B is the vertex, so it is in the middle, D to B to C, okay? I'm going to look at the numbers below it, okay? So kind of erase that because you can't see it, but it's going to be this angle right here. And this is where, guys, you have to use a little bit of common sense, okay? All right, a little bit of common sense. that has a wide opening, okay? It's a lot bigger, so we're going to use the bigger numbers, okay? So we're going to look at 120, so that is going to be 120 degrees, okay? And that's for DBC. All right? So just please use a little bit of common sense. And what I think about is like we have a 90-degree angle. If we have a right angle, that's right here, okay? So if you look, that angle DBC has a wider opening than a right angle, so we know it has to be greater than 90, okay? Just be aware of that. So moving on, angle addition. So for this one, they're just gonna give you, and this is where you kind of just play around with it, but we got these sliders over here, and so they're making, this picture. And so this is just to help you kind of play around with it, that if we increase this angle, then the total angle. So the total angle is 83. So that's a measure of angle ABD. So that's the whole thing is 83 degrees. And then it shows you how that if we split that up with that ray BC, that we can kind of make it bigger, smaller. We can make that part bigger, smaller. So this is just something to play around with, all right? And then the last thing that I want to talk about is congruent segments, okay? So congruent segments, there's different ways to denote that something's congruent. I'm sure you probably have seen this, all right, in your previous math education. But if we are denoting something is congruent with lines or segments, we just use, and I just call them like a little tick mark or something like that, a little mark. Okay, so we know that if you look on here, we have AB and CD. It has those two segments, so they are congruent. Okay, so that just means if AB is 5, and I hope you guessed it here, that CD is going to be 5. Okay, so whatever it may be. All right, now there might be a drawing where we have, like this, a triangle, and we have these two are congruent and this is not congruent. So they might use more than one mark, okay? And that's what it's saying down here, is that there might be more than one tick mark. So if we have PQ and RS or something like that, and they use two tick marks, then you just match them up. Okay, it's kind of like a matching game. You just match up the marks. Same thing over here with our congruent angles. If you notice, we have angle TUV and angle XYZ. If you notice, U and Y are the vertex. That's why we're there in the middle when we're naming this. Okay, they have one mark there, so that means that they are congruent. And again, down here, we have angle FGH and angle JKL. They have two marks. Call them the arc marks. Kind of like the arc marks. Rhymes, Hey, what's the arc mark over there? All right, so anyways, arc marks, two of them, match them up. That's all you have to do, okay? Guys, this stuff down here, don't worry about it too much for right now. Just kind of look over it, have it in the back of your brain. We're going to come back to this when we do like proofs and everything and actually use these properties, okay? But for right now, as long as you know congruent segments, congruent angles are going to be good. So guys, that takes us through the whole kind of first 1.1. So I know that there was a lot in there, but hopefully it was helpful and you can kind of see the tools and everything like that. And guys, this video, I took you through everything just because it's our first video. Am I going to do this on every single video after this? Probably not. Probably not. So I just want you to be aware of that. I know this might be a little bit longer of a video, but I just want to make you aware of everything, show you how everything works and everything like that. So the assignment you have to complete is this first 1.1 assignment. So that's where it'd be good to watch this video before you come into class. Look over the assignment before you come into class. All right. And then you're able to ask me questions when we're in class. Because when we're in class, it's going to be a lot of working through problems, helping you get through your assignments so that way you don't feel stranded or anything like that. So it'd be a good idea to look through this stuff before coming to class. Okay, guys? So if you have any further questions, please, ask them in class. If you forget something, you can always, shoot me an email and I can help you out in any way. Okay. All right. Thanks, guys. Hope you have a great day and a great start to the school year.